So today we're going to explore how to plot spatial data in Python. Specifically, we're going to explore how to take some simple longitude, latitude data and then put it on top of a map. This is just a simple example, and we're following along the web page shown here, so also you can navigate here if you want to follow along, although we deviate pretty quickly from what's shown here so that we can take a slightly simpler approach. It's just that if you want to understand or see more of this example, you can follow along here. Now, one of the things we've done in the past is that we've had CSVs on our hard drive that we have pointed to when we want to import data. I'm going to show you that you can also just import things directly from the web. And so we're going to pull data directly from this website shown here, which is associated with this tutorial here. In here we have data sets for things like housing in California. And so here is the housing.csv. And so one thing you could do is that you could download this housing CSV onto your hard drive and load that directly from your hard drive into Jupyter Notebooks. But the other thing that you can do is that you can just point your Jupyter notebook or your Python script at this website here. And so let's see an example of that. Here what I've done is I've just posted in some text or some commands that I didn't feel like would be worth typing out for you. It comes again directly from the tutorial we saw before and was posted in the assignment. So you can just paste that directly in. I do want to point out a few things about this. One is that we've imported OS. This is a package that lets us handle things in the operating system. We've imported a library called tarfile, which lets us handle tarballs, which is a type of archive. Kind of like if you've ever used like a zip file where something comes in and it's compressed. It's a bit like that, except they're called tarballs. And so this lets us handle file formats like that. There's a few others about URL lib, which lets us then point to URLs in order to get these data sets. And here what we're doing is we're setting up some variables. This is a variable that's a string, which is the address associated with the data sets. And so if we go back here, that's what you'll see, is that here is this HTML address, and we're setting that as datasets URL. We also have housing path, which goes from datasets to housing, and that's exactly what we saw before. If I click on housing, we'll basically go datasets and then housing, and so it's just telling it that we should look inside of there. We also have housing URL as datasets URL plus housing TGZ, and that's basically like the tarball style archive. And so we're telling it, why don't we pull from this compressed file here. Then we have this block, which is a user-defined function. So things like when we used print in the past has been a function that's built into Python. It isn't always the case that we would like to use only functions that are present and already pre-built, and indeed a huge amount of the power of programming that we have comes from our ability to build our own functions. And basically the syntax for this is that we say define, and then we give it a function a name, and then in between two parentheses we define what we would expect to give this particular function. And then we have a colon, and then we have an indentation, and we provide all the steps that will happen in that function. And so now if we want to perform all the steps down here, rather than typing them out over and over and over again, we just use this name here to refer to it. Now that's a lot, and we're not going to worry about it too much here, although we will see a simpler example in just a moment so that you can kind of see how this function works. So let's go ahead and get this into our active kernel. And you can see that I've let this sit long enough that my kernel's expired, so I'll click on no kernel and say select, and now I have Python 3 back. Sometimes it sits long enough that you can't just restart the kernel, and then again you'll have to just reload this whole. But let's go ahead and hit run. That puts all of this into our active kernel. So now we have access to it. Nothing happened because there was no output. It just moves us to the next cell. What we've done so far is really nothing. We've just defined this function, and then we can use it later. So let's actually go get the data. We haven't done anything. We've just defined variables, and we've said maybe how we're going to go ahead and get the data. So let's actually get that data. One thing we're going to do is we're going to introduce another idea or another library called pandas. And what pandas is a library that lets us handle arrays of data in a way that looks a little bit more like what we expect if we were using Excel. In Excel, we'd have a series of columns that all hold data, and we had seen that we can kind of reproduce an idea like that using lists or using arrays, but in pandas, this is much more clear that we have that sort of structure. And we'll see that in just a second. We don't want to have to write pandas every single time, and so let's import it with a nickname, PD. So now we can just write PD every time we want to call pandas. Now, let's write our own function. And so let's say define load housing data, because we're going to look at housing data. Actually, I spelled this wrong, and that's going to cause me problems down the road. So load housing data. And then we said that what we do is we, between two parentheses, type what we expect it to get. So we expect this to need the housing path, which equals, let's say, housing path. Oh, these should all be capital letters. Housing path. And so we're saying that there's a housing path, but that housing path is equal to this all caps housing path here. Then we say colon, that ends the definition of this, the invocation of the definition of the function. And now we'll supply what this function actually is. And so let's say that we want to do something like read a CSV file. What I could say is CSV path, all lowercase, CSV path equals, and so I'm just setting a variable here again, OS, that refers to the library up here that lets us handle operating system things, and then dot path dot join, and so we're going to put several things together, dot path dot join. What we're going to do, this is a function in its own right, so what we're going to join together is housing path and housing.csv. And so what this essentially is going to do is it's going to take the housing path that we had before, which is datasets housing, and then we are going to say that at the end of that, let's just type in housing.csv. And so essentially, if I go back here, what we're doing is we're now pointing it at this file here. Then what I say is let's return. So one way to end functions is to return them. And when we return them, what we're trying to say is like this function is going to give us back some kind of value. In this case, let's make the value that read CSV file. So before we had read CSV files by using the CSV library, it turns out that pandas has its own built-in ability to read CSVs. So we'll invoke that by saying PD, which is our nickname now for panda, dot read CSV. And then we're going to say what we want to read is the file that's present on the CSV path. And so in this function, if we invoke it by using this name, what it will do is it will take this housing path, which was defined up here. Then it's going to use this OS path join function to append housing.csv on it, so that when it goes to look at CSV path, it will be looking basically at this file here. Then we return an object which is the result of reading the CSV file that we find at that path. So essentially we tell it, go here, read this, and then return the results of that reading as this function. So how do we use this? Well, we could use this a couple different ways, but how about we say fetch housing data like this. And what this does is it invokes this up here, which again, we're not going to worry about too much about what's happening. Then we say housing equals load housing data. And load housing data is this function. So now housing becomes the value of this function, which is the read CSV file. And so after we read the CSV file, that will be what this becomes, and that equals housing. So housing will become our read CSV file. If I want to see what that looks like, I could say something like housing. And then if I ran this, it would display that. But this data file is actually very long, and I don't want it to take up all this room. Wouldn't it be nice if I could just see the top so many rows? And one way to do this, since it is a pandas object, is just to say head. And when I say head, it's just going to show me basically the top 5 rows. Okay, so let's see what happens. I've already run this cell, so I don't need to do it again. I can now just run this cell here. If I hit run, what you'll see is it took a second because it had to go to this URL and then access this file and then put it in. Then that's what housing is, and I'm looking at the top 5 rows. And what you'll see is it kind of looks a little bit like what we'd see in Excel. I have a column, a column, a column. Each one of these columns has a heading up here. Later on, this will become very important, not in this tutorial, but in the ones that follow. Then we have the index for each row. So you can see I have row 0, row 1, row 2, row 3, row 4. And so one of the differences from Excel is we start at 0 instead of 1, but that's because we're using Python, which starts counting at 0. And so you can see it kind of looks like what we'd expect. Several columns of data, each having rows that we can specify this by. So one of the columns is longitude, and one of the columns is latitude. And so you could imagine that we could use that to plot whatever this data is. And this data is essentially information about the age of houses, the total rooms that all the houses together have, the total bedrooms that all the houses together have at each one of these locations. And so these locations actually then correspond to cities. And these cities are going to be in California. We have the population for each of these cities, the number of households for each of these cities, the median income in that city, the median house value in that city, and then kind of where it is next to the ocean, in case we were interested in that information. That all came when we read this .csv file that we're looking at here.